Hello everybody, this is the video clip for chapter 3 and we are still in the application of the derivative, okay? And for this video clip we are going to use a property of your f prime and the f double prime together with the shape of the graph or the curve of a function, okay, to try to sketch the curve, okay, of a given function. So don't forget that if this one is positive, then it means that you have increasing, okay, function. If this one is negative, then you got a decreasing function. If this one is positive, you got a concave up. If this one is negative, you have a concave down, okay. And also in order to find or to draw a curve, okay, sometimes you need to have the asymptote, right? And for the asymptote we have a vertical and the horizontal asymptote, okay, as we are going to work together with you throughout all these examples, okay. However, to be more specific, okay, in order to draw a curve, okay, neatly, we may need something else as well, okay. So let's try to do it like step by step. The first one, you need to look for a domain of a function f, and this function is simply a polynomial. You see, this is x, this is like x cubed, so it is a polynomial, so it means that the domain of this kind of function is the whole real number. The next thing that you may need to find is the x-intercept. By x-intercept, it means that you let your y equals to 0 and then solve for x. So if your y is 0, you have this equation, right? So it means that your x is 0 and also 4, you see. And for the y-intercept, you are going to let your x equals to 0. So if your x is 0, then immediately your y is also 0. So here's the y-intercept. So it means that roughly speaking, okay, so here's one of the point that your graph must be passing through. There is another point that your graph must, yeah, 0 and 4, right? Those 2 points will be the 2 points that the graph will passing through, okay. So if you want to find the horizontal asymptote, you need to find a limit, right, as your x goes to either positive or negative infinity of this function. However, if you take a look, this one is like x raised to power, right, has no fraction. So if your x like pretty large number, then it will be a large number. Or if your x is large in terms of a negative, then it will be a large number in terms of negative as well. So the horizontal asymptote we doesn't have, okay, or we just say that this one does not have the horizontal asymptote, okay. So for the vertical as well, a vertical usually will determine by this domain, okay. If you know there's no fractions here and your domain is like the whole real number, then it means that you can find the y value for each and every x value, okay, on the real line. So there's no vertical, you know, assumption. So this means that the vertical asymptote also does not exist, okay. So we don't have the horizontal and the vertical asymptote. To find your f prime, one way is that you can, you know, expand all the cube thing, but if they already give you like in terms of factor like this, you keep it as a factor, okay. So it is the what, the first derivative of the second, which will be 3, and then x minus 4 square plus the second, okay, and then derivative of the first, and then you see that it will be easily for you to pull out a common factor, which is x minus 4 square, and then you end up with 3x and then plus x minus 4, okay, and it is what, x minus 4, you can do it here to be x minus 4 square and 4x minus 4, right? Is it? Or you can say x minus 4 square and then the 4 can be out, right? And here you have x minus 1, okay? Okay, so the sign for the f prime, this is the sign for the f prime, depends on 1 and 4, okay? If you are looking at this one like 5, okay, so here is always positive, right? There 5 minus 4 will be positive, so here's positive. If you looking at like 2, okay, so this is always positive, 2 minus 1 is positive, so will be positive all the way. And then let's say 0, so here is positive again, right, because of the square. This is negative, so it will be negative, okay? So this is the side of your f prime. How about your f double prime? Your f double prime can be found from this one as well. Oh, maybe this one may be better. So it will be the first derivative of the second, which is 1, plus the second derivative of the first, which will be 8, and then x minus 4. So again, you can pull out a common factor, which is 4 and then x minus 4, and you end up with x minus 4 on this one, you see, and 2x minus 2, because you still have the 2 here, okay? So you have 4x minus 4 and 3x minus 6, right? Or it is like 4x minus 4 and 8, right? Because you can pull out another 2, is it? And then x minus 2, right? Oh, not 8, sorry, 12. 4 and 3, it becomes 12, right? You can pull out the 3, so that will be x minus 2, okay? So this means that if you want to look at the side of your f double prime, it depends on the 2 and the 4, okay? And you again can plug in like 5, so it is positive, positive, so positive. You can plug in like 3, so negative, positive, so negative. You can plug in 0, so it is negative and negative together will be positive, right? Okay, so our critical number is right here, right? The critical number, you see, is the one that your f prime is 0. So the critical number is 1 and 4. And your f is increasing, so it means that it determined by your f prime is positive, right? So from 1 to 4 and from 4 to infinity, is it? And your f is decreasing from negative infinity to 1, so determined by your f prime is negative. A local max, okay, a local max is at the point, so this one is going down and then it's going up and then it keep going up, right? So we have only a valley, so no hill, so this one has no local max, okay? But over here it's going down and up, so here is the hill, so the local min occurs at your x equals to 1, so you replace your x equals to 1 here, so you have 1 and then minus 3 cubed, or it is 1 and negative 27, right? Your f is concave upward, so the concave up depends on positive side of your f double prime, right? So it concave upward whenever your x is from negative infinity to 2 and from 4 to infinity, and concave downward in between 4 and 2, So the inflection points, okay, the inflection point, you can see it more clearly from the side of your f double prime, right? So the point that your side of f double prime changes, so it is 2 and the 2 and the 4 is not the points, right? So you need to find the what? A 2. So the points are 2 and then f at 2, which is 2, and then a 2 minus 4, which is negative 2 cubed, and then a what? A 4 and a 4 and 4 minus 4 is 0. So this one is not that difficult, okay? So here this point is actually what? 2 and negative 16, right? And this is another point. So use the above guideline to sketch the curve of the function f, okay? So let's look at all the guideline that we have, okay? And then we try to draw it. All right. Oh, it should be somewhere here, okay, because it will passing through 0 and 4. All right, and at 2, okay, it will be negative 16, so it will be all the way down somewhere here, and at 1, so it may be at 1, okay, it will be all the way to negative 27, right? So at 2 will be negative 16, so it's somewhere here, okay? So what does this mean? We have altogether the thing that involved will be 1, 2, 4, right? So if it is beyond 4, okay, it is concave up increasing. So increasing and concave up. In between 2 and 4, so it's still right here, right? So it's increasing still, but concave down. And then from 1 to 2, 1 to 2 is still here, so it's increasing, increasing, and then 1 to 2 is right here, right? Concave up. Okay, the last one beyond 1, so it's decreasing, concave up. Okay, so decreasing, concave up, so it means that it will go down, right? And then increasing concave up, it means go like that, right? I mean the curve decreasing concave up, increasing concave up, increasing concave down, and then increasing concave up, right? So the graph will look like that, okay? So it will look like this one going that way, and then going that, and then going like that, okay? So you combine this shape with all the points that it's passing through. So from here, okay, it's going to passing this one, right? And then hit this point, okay, and starting going up, okay, and from this one it is starting going downward a little bit and then going up like that. Are we good? Okay, so the graph or the curve, okay, the curve look like this. Okay, okay, this one keep going up because the limit as your x goes to negative infinity is going to be infinity, as well as if your x goes to infinity, it goes to infinity, right? Okay, so here's the local mean, okay, here is the what, inflection, the two inflection points, okay, so it's look like that. from the guideline. So let's look at another one. This one, we already given a domain, okay, from -1 to 4, and you need to fill in some other things. Okay, the first one, if you need to find the x-intercept again, so you are going to let your y equals to 0. This one you can pull out the common factor, right, which is x raised to the power 1/3. Okay, so here it means that your x can be 0 and 4. Okay, and your y-intercept is simply if your x is 0, so your y will also 0 as well. Okay, so it look like the same, right, that it passing through these 2 points. The horizontal asymptote, if you look at the limit, okay, as your x goes to either positive or negative infinity, but this one actually there's no need for the horizontal asymptote. Why is that? Because your x is kept between -1 and 4, so your x cannot go beyond that point, right? So this one has no horizontal asymptote, and this one has no vertical asymptote, because at each and every x here you can be able to evaluate the y value. Okay, so what is your f prime? Your f prime, let's look at the original one. So we have 4/3 x raised to the power 1/3, and then minus 4 x raised to the power 4/3 x raised to the power 2/3, right? Or you can simplify a little bit, it will be this one, and then x raised to the power 1/3 minus x raised to the power 2/3, is it? So you combine it, it will be 4/3 x minus 1 over x raised to the power 2/3. Okay, this one will be positive all the way, right, because of that square. Okay, so the only thing that will determine the sign is that x minus 1. Okay, and actually if you really take care of the limit, okay, as your x goes to 0 on the left of f of x minus f at 0 over x minus 0, okay, you see that this one is actually x raised to the power 4/3, x raised to the power 1/3, and then over x, right? So you have the what? X raised to the power 1/3 minus 2 over x raised to the power 2/3, is it? As your x goes to 0. This one is okay, but this one will be a 2 over a small number. It will goes to a negative infinity. So it means that the derivative at 0 cannot be found, right? Okay, so this one you make a little bit comment that this one does not exist. Are we okay? And this formula can be used whenever your x is not 0. Are we alright? And that 0 is inside the interval under consideration. So it means that if you really want to see the sign of your f prime, you need to have your 0 coming to play, and then 1, okay, which is there. Okay, however, if it is beyond 1, you can check the sign again, it will be positive. If it is less than that, it will be all negative. Okay, and your f double prime, you can continue from here. We have 4/9 x raised to the power negative 2/3, and then plus 8/9 x raised to the power negative 5/3. Are we okay? So we have 4/9, and then 1 over x raised to the power 2/3 plus 2 over x raised to the power 5/3, right? So you are going to combine it. So we have 4/9, and then you multiply by x raised to the power 3/3, right? So you have x plus 2 over x raised to the power 5/3. Okay, So again, your f double prime will also does not exist, because I mean f prime does not exist already, so it means that your f double prime will also does not exist. Okay. Okay. Oh, by the way, this one cannot go beyond -1 and 4, right? So this one you have -2 and then 0, right? But the -2, it is out from this interval, right? So it means that here -1 and 4 right here. Okay, so if it is beyond uh, 0, it will be positive all the way. If it is less than 0, it will be negative. Okay. Okay, we don't care about the one beyond that. So what will be the critical number? Okay, so as we told you, the critical number can occur at two places. Okay, so the one that your f prime is equals to 0 and the one that your f prime does not exist. So a critical number will be 0 and 1, and your f will be increasing whenever you start from 1 to infinity, decreasing whenever you start, oh, not infinity, sorry, to what? To 4, and then this one from -1 to 0, and I'm sorry, -1 to 0, and from 0 to 1. Okay, decreasing, it means that your f prime is negative. So the local max, again, it is going down and then going up, so there's no hill, there's valley or only, so there's no local max. But a local mean occur when your x is 1. Okay, and you replace your x by 1 in here, so you have 1 raised to the power 4 over 3 minus 4, which is 1 and -3. Okay, where's the absolute max? Okay, so to find the absolute max, you need to looking at the value at the end point as well, right? So let's see the value at the end point. Okay, so if your x is -1, okay, if your x is -1, your f of x will be what? -1 raised to the power 4 over 3 minus 4 raised to the power -1, multiply by -1 raised to the power 1/3. Okay, so here will be 1 and then plus 4, right, which is 5. Okay, and if your x is 4, this will be 4 raised to the power 4/3 minus 4 and then 4 raised to the power 1/3. Okay, but it happened to be what? 4 and 4, this one, it will be 4 raised to the power 4/3, so it will be 0. So the one that is maximum is right here, right? So a absolute max will be -1 and 5, and the absolute mean will be this one again, right? The negative will be less than a 0 here. Okay, so the one that concave upward, okay, the concave upward is determined by f double prime is positive, so it is from 0 to 4, and concave downward is from -1 to 0. Okay, and the inflection point is the one that change the concavity, but inside the domain under consideration will be only at 0. So if your x is 0, your y must be 0 as well. So you are going to combine the whole thing together. So now it's from -1 to 4, right? So the point under consideration, you have 0 and 1 here. So if it is beyond 1, it is increasing, right? Okay, increasing, concave up. And then between 0 and 1, decreasing, concave up, right? And less than 0, decreasing, concave down. Okay, so what else that we have? We have from -1, right? So let's say here -1, and then 0, and then 1, 2, 3, 4. Okay, so we know that it will cut your x at 0 and 4, so it might passing this point, it might passing through this point. Okay, and we know that if your x is 1, your y is -3, right? So if your x is 1, your y is -3. So let's say it's here. Okay, 1, -3. And then if your x is -1, your y is 5. Okay, let's say -1 and 5. And then if your x is 4, is 0 is over there, right? Now we have this one going down like that, and then this one still down, going down, right? Because it is decreasing, but the concave is concave up, and then later on it will go up like that. Okay, and this will be pretty sharp because at 0 a derivative does not exist, remember? So it will be the shape will look like that. Okay, pretty sharp here, and then it will pretty sharp here as well. Okay, and then from here it will go up like that. Oh, not go up too far, because you are going to stop at what? You are going to stop at 4. Okay, so here's the absolute max, there is the absolute min as well as a local min. Okay, are we all right? So we are going to stop this video clip right here first. Okay, we still have a little bit more of the example, but we are going to cut each clip into like a small period. Okay, so we'll see you on the next one with a more example on curve sketching. Bye bye.